Hello students, uh, welcome to the course Illumination Engineering. Myself Milan Sasman from Department of Electrical Engineering of JIS College of Engineering. Today we will discuss the electromagnetic waves, and in last class we have seen what are the basics of electromagnetic waves and how they actually propagates, and today we will see the what are the different electromagnetic waves or based on their wavelength, based on their frequencies. So the whole range of electromagnetic waves, we can say the frequencies that is called as the electromagnetic spectrum. Electromagnetic spectrum. Spectrum means the overall all the electromagnetic waves. They are continuously. They having the different wavelengths and also having the different frequencies and different parts which interact with a matter in different ways. It means suppose a few ranges of frequencies or few ranges of wavelength which interacts with one part and another in part of this electromagnetic waves which interacts with the another few instruments. So based on that, based on their wavelength, based on their frequency, they are having the different applications. So the one human can see are called the visible light, a small part of this whole spectrum. So this spectrum having a different range as we have discussed. So this range means it can be possible of, suppose as an example, if we consider that the wavelength which having in the range of 10 to the power minus 18 centimeter to it may happen that 1 kilometer wavelength. So based on these values, there are different names are there also, and what the light or whatever things we can visualize by our eyes, by this human eye, they having a particular range. This range of light, that is called the visible light. And if we look this picture carefully, the picture says that the electromagnetic spectrum having the different wavelength, and it clearly says from the wavelength in meters it's given over there, that is 10 to the power minus here is 10 to the power minus 1, minus 2, minus 3, and in left hand side if we go for that is 10 to the power minus 8, 10, whatever meters are there, and in right side if we consider that is the wavelength 10 to the power minus 12, 10 to the power minus 13, 10 to the power minus 15, 16, whatever, and based on that there are the different names are there. Sometimes we may call it as a visible light, sometimes we may call it as a X-ray, sometimes we may call it as a microwave, sometimes we call it as a radio waves, and different things are there. And the device which detect other frequencies, if we consider the antenna, that we know that in previous days in our radio or TVs that consist with some antennas are there, and if we put these antennas on, or if we increase this antenna portion, and clearly the signals are coming clearly, and we can get the voice very clearly. And otherwise if we off this antenna portion, then few distortions are there. We have experienced this thing in our radios in our previous days. So this antenna of a radio that detects the radio waves, right? Similarly, the radio waves, which actually are the lower frequency of electromagnetic waves and having the wavelength that is longer than 1 millimeter. So wavelength that is longer than 1 millimeter, that is the radio waves, and these waves must have turned into sound waves by a radio before we can hear them. And as this radio by this antenna, they are just interacting with these waves having the wavelength greater than 1 millimeter, and obviously it's the radio waves, and whenever from the radio we are getting the output as a sound. So this wavelength, particular wavelength, radio wave, they are converted from this converted to sound, and then we are getting this sound. Okay, now for this radio transmission, if we consider the radio station which changes the sounds to electromagnetic waves, it means suppose if we consider one radio station, what happened actually in radio station, one the person who is speaking over there, one person is there, generally we can say that is radio jockey that is over there, and who speaks continuously, and in our where we are in our homes or in our different places, and we can hear his voice. So how it actually happens? No, someone is speaking over there, that is the sound wave, and in radio station this sound wave that is converted to electromagnetic waves, and these electromagnetic waves is nothing but in order of radio waves, and this radio wave that is reacts with our antenna that is fitted with our radio. So this radio, by this antenna, it receives that signals. That signal means that waves. This is nothing but that radio waves. So the main voice that is generated, that is the sound. So first sound is converted to radio waves in the radio station, then this radio wave is distributed, right? This radio wave is interact with the antenna that is fitted with our radio, and again whatever signal received or whatever radio wave received by this radio, again this radio waves is transferred to sound wave, and after that we are getting this sound from the radio. So this is the overall process of transmission. So so it means the normally this is nothing but the long distance or the distance communication. So if we consider that it's a one type of communication, so there the conversion of this sound wave to radio wave, and again radio wave to sound wave conversion is always there. Right? Okay. So the next is, how does a radio receive different station? So different station means already we know in previous days we use AM, then it comes to FM. AM means that was there was the amplitude modulation was there, and after few days it comes the frequency modulation. So for each station they having the particular some amount of either in terms of amplitude or either in terms of frequencies. So the radio station, so the each station broadcast a certain frequencies which you tune in by choosing your frequency, and the carrier waves which the frequency of the electromagnetic wave that a station uses, that is called the carrier waves, and there are the microphones are there, the microphones which convert the sound waves to a changing electric current or electric signal and containing the word and musics in this way. So in previous days when we use the AM, it means the audio the amplitude modulation. For this amplitude modulation, the sending or from the sending end, actually they sends the different the different radio waves having different amplitudes, and whatever the radios are in our hand, they receive that signals, that radio waves, and again transmit converted this radio signal to sounds, and we are getting this sound, and based on this amplitude, or based on this amplitude means based on this energy, we are getting different channels, and after that this concept has been changes to amplitude to frequency. It means nowadays we transmit this radio signal in the concept of these different frequencies. It means one channel use one range of frequency and the another channel uses another range of frequency, and if we want to go for a particular channel, so we have to set a particular frequency, and if this frequency is set, then this particular signal will be with us. Okay. So here the same thing is given there, that how the radio receives the different types of stations, different types of signal, and how they are providing this. Okay. Okay. So the next that we have already discussed, that is what is AM radio in last days, in previous years we are habituated with that thing, in amplitude modulation technique. So in amplitude modulation technique, where amplitude changes but frequency was fixed. So in amplitude modulation, where the frequencies, the range is 540,000 or 540 kilohertz to 160 megahertz. 160 megahertz, usually listed in kilohertz ranges, so that is 540 kilohertz to 16 megahertz, we can say, but that's better to say. That frequency they are for a within the frequency ranges, they use a particular frequency where amplitude was the different one. But in case of FM, that we have already discussed, they use where the amplitude are more or less same, but they use the different range of frequency. Range of frequency means frequency, it may be from megahertz to terahertz or millions of hertz, megahertz, in megahertz ranges of frequency, not the kilohertz ranges frequency. So in audio the amplitude modulation technique, where we use the different range of amplitude for a particular signal or for a particular radio waves, and having the frequency in a particular frequency, and the frequency ranges was in kilohertz ranges. Okay, and now for this frequency modulation, the technology changes. Instead of changing the amplitude, just they are using the different values of different frequencies of waves. Because if we want to use the previous technology where the amplitude modulation is there, if we want to change the magnitude or amplitude, there may be some distortion, or to send the higher amplitude frequencies from one place to another place, it means a huge amount of energies are there, so the transmission is very much problematic. So that's why we have shifted. And if we go for the frequency variation, then our the ranges is the very wide ranges are there. We can use the different frequency for a different particular channels, right? Now we comes to television. If we comes to television, it uses uses radio waves to send the electronic signal in a carrier wave, and sound is sent by frequency modulation. Color and brightness is sent at the same time by by amplitude modulation signals. So if we shifted our concentration from radio to television, in television it uses both the concept, both the amplitude modulation technique and both the frequency modulation technique. So the sound, the transmission of this sound, that is based on this frequency modulation, and transmission of this color and brightness, it means the pictures that we can see in our television, that is sended by using the technology of amplitude modulation. And the next thing is cathode ray tube. Generally we consider this as a CRT, cathode ray tubes. So what is it actually? And in our previous days we have seen the TVs that is in larger in size and in back sides also. We can say that picture tubes are there. Generally we used to say picture tube. So picture tube, this is nothing but the modified version of the CRT or this cathode ray tubes, or in previous days the computer monitors also, they are there. So the vacuum tube, it means the cathode ray tube, it means there is a vacuum, and within that suppose if we consider one electron guns is there, and electrons are emitted from there, and that electron is spotted on the screen, and where the electron is spotted on the screen, and based on that we are getting some lights, and we are getting some pictures, or we are getting some lights. And already we know the technology of the CRT in our measurement section, that we have seen that how the CRT or the cathode ray tubes that works actually. Okay. Now comes to the part telephones. How it comes? Telephones means just we are taking in our cell phone in our hands, and just making the sounds hello and in hello, and in other sides who is in the receiver end, he can also receive the sounds, and if he replies also, then the same we can receive also. So here is again the conversion of these waves. It means sound waves to microphone is generated to electrical signal, then again it's converted to radio waves, and again it transmitted one portion to another portion, and transmitted to one portion to another portion means to the tower, whatever the towers are there, the microwave towers are there, and the receivers are there obviously after towers, and going to the receiver end, and it receives the signal. Then this electrical signal is received, and then again this electrical signal is modified, or this modulated or demodulated, that will be converted with electrical signal to the sound wave again, and that by speaker. Okay, and that's how we are getting the communication from one person to another person, and that is used in our cellular technology. So in details, it's given over here that cell phone and cordless telephones are the transceivers and devices that transmit one signal and receive another radio signal from the base units, and you can talk and listen at the same time because the two signals are at different frequencies, right? So it means whatever you are talking about and whatever you are listening, that's at the different. It means one part is you are whenever you are talking something, that signal is sound, that is sound wave, and this wave is converted to electrical in the form of electrical charge or electrical current and voltage, and that is again transmitted to the receiver portion. And similarly whatever you are listening, that means the same technology that is happening just few seconds ago, that is that was in the opposite side, it means in the other person's sides, and that signal comes to you, and this electrical signal is again converted to the sound signal, and then again you can listen. Okay, so the same thing is here also. How the pager works also. The pager, that is nothing but a used to communicate in previous days also. The pager is a small radio receiver with a particular phone numbers. A caller leaves a message at a terminal and with a call back numbers, and that message is delivered to the particular person, and with respect to the number whatever is predefined over there, right? Okay, now comes to microwaves. If we consider microwaves, they are the microwaves are basically radio waves with a wavelength less than 30 centimeters and higher frequency. So from radio waves, if we shifted little bit smaller wavelengths, that is less than 30 centimeters, they are called the microwaves. And this microwave, the cell phones, satellites that uses microwaves between 1 centimeter to 20 centimeter for communication. In microwaves, in microwave ovens also, a vibrating electric field caused by water molecules to rotate billions of times per seconds, causing the friction and creating tea, which is which hits the foods, and we generally in our household application we use this thing. Then comes to radar. How radar is work? Radar means the radio detecting and ranging, or radar that is used to find the position and speed of objects by bouncing radio waves of the object. Okay, so this is the another application of the electromagnetic waves as a radar. Similarly, the magnetic resonance imaging, that is called MRI, and this magnetic resonance imaging, these terms that is very important in the terms of medical structure. If we consider that magnetic resonance imaging, and to diagnose the illness with a strong magnet and a radio wave emitter and receiver. So this is nothing but the interference between these two signal, and as a result some protons they are coming out and they react with the magnetic part, and as a result we are getting some images, and this is called the magnetic resonance imaging. And basically this MRI technique that is used for the medical portion. Similarly, for communications, in case of satellites we use these electromagnetic waves. Similarly, for global positioning system, the GPS systems also we use these electromagnetic waves. Next is infrared. Infrared, that is for to communicate with any remote elements, like suppose by using a remote we are controlling any TV, or we are controlling any CD player, or we are controlling any AC units, whatever we are using, that is by using the infrared, by using this infrared waves. And similarly, by using that infrared we can also take some images also, that is infrared images. This is the one another application of this infrared. The next comes to visible lights. Visible lights means our from these electromagnetic waves, uh, the human eye which can sense the portion of this electromagnetic waves, that is called the visible lights. And this is the fundamental lights there are there. The fundamentals, there is a blue has the shortest wavelength, and red is the longest wavelengths, and we have we know the normal structure, that is of Vibgyor, that we have seen in our class 12 standard. And based on their wavelength we can see, we can identify different types of colors also, right? And the different ranges of frequency, based on different ranges of frequency some applications are given over there. Some ranges of frequency which is using for images, and which is used for visible light. Some portion is visible, some portion is used to television communication, some portion is used for radar communication, some portion is used for ultraviolet as a UV ray, some portion of this electromagnetic waves which is called as a infrared. Like that, the different ranges of frequency, that is having the different names, or having the different applications, right? Next is ultraviolet ray. These electromagnetic waves with wavelengths from about 400 billions to 10 billions of a matter, right? And have enough energy to enter the skin cells. So it means as the wavelength are particularly over there, and based on the wavelength they having the different frequencies, and based on this wavelength, and we know A is equals to h nu if we consider. So they having the different energies are there, and this ultraviolet ray which having the energy which can penetrate our skin cells, and as a result we can use this ultraviolet ray to the cancer treatment also, right? And there are the different another applications also in medical supplies, and in fluorescent powder absorbers, or as a making of some disinfectant, like that we can use this ultraviolet ray. And here is a picture that clearly shows that the different types of lights, and having the different types of application, and obviously based having their different frequencies, right? So it clearly says that our visible light which having only the range of 10 to the power frequency having 10 to the power 15, in the range of 10 to the power 15, that is the visible lights only. Or having the frequencies which is less than that, they are nothing but the lower order frequency, that is used to that is used for the communication, satellite communication, radio, TV communication, or mobile communication, or infrared communication. And the higher order frequencies they are using as a UV, named as a UV or X-ray, like that. Okay. Now comes to the term ozone layer. Ozone layer, we know the ozone layer, that is the layer of ozone gas, that is we know that the O3 that is above the 20 to 50 kilometers above the earth, the ozone gases layers are there. And molecules of 3 oxygen atoms that creates ozone, and we write this ozone that as a O3. And what is the purpose of this ozone layer? That ozone layer purpose is which absorbs the sun's harmful UV ray. So this UV ray which having is nothing but the electromagnetic waves, and this UV ray which is which having already we have seen which having the enough energy to penetrate our skin cells, and that's why we can use this UV ray for the cancer treatment. But if this UV ray comes to our body normally, so it can harms our body. So as a normal, we can consider the normal protection. The ozone layers are there which can absorb this ultraviolet ray which is coming from the sun, and by this ozone layer that is absorbed, and so that we are over here and we are safe, right? So if at the ozone layer, this ozone layer, and nowadays due to some pollutions, this ozone layer that is decreasing day by day by using of several pollutions by creating by cars, and by CFC, it means by chlorofluorocarbon, that is used in AC, refrigerators, and several cleaning fields, etc. So the most thing is that as a electromagnetic waves, as we are getting some useful part of this electromagnetic waves, similarly we have the electromagnetic waves which uh, can harm also. So we have to protect ourselves from that rays, and the one natural protection is over there, that is nothing but the ozone layer, and obviously we have to save this ozone layer and by this pollution. So it may be one our motto that we have to reduce this pollution, right? Okay. So the next thing is, if we do not concerned about this ozone layer depletion, then what happens to our humans? It may have an great adverse effect to the humans if this ozone depletion of this ozone layer is continuous, right? And as a X-ray and gamma ray, this is also electromagnetic waves and having the high energy. By using this X-ray, we can get some photos of our broken parts, and the internal structure, we can get some images of some internal structure by using this X-ray and gamma ray. Okay, so these are the different types of electromagnetic waves, and based on their different values of wavelength or different frequency, these rays are utilized in different portion that we have already seen, and having different names, different activities, and in our daily lives also there are several applications are there where we uses this electromagnetic waves. Okay.